Hey everyone, this is Doug Hennick, Product Manager for Helius PFA, which includes the Advanced Material Exchange utility. Today I want to talk to you about what is coming in the Helius PFA 2016 SAP. SAP stands for Subscription Advantage Pack. It is offered to anybody who is on subscription, which means that if you own the product, you are on subscription for Helius PFA. So to begin, I want to talk about term licenses. So Helius PFA is a term product, which means that you rent it for a specific timeline. And in Autodesk, when you have a term product, that means you get to do some pretty cool things. And one of those is that you get to release incremental updates to your products, where there's not just updates, there's actually new functionality. And that's what this SAP does. So for those of you who don't know, Advanced Material Exchange has been around for about a year now. And in that year, we've had about 3 releases. So we're iterating really quickly, and that affords a lot to you as a customer in that you can get these updates pushed to you quickly. So last year when we had our incremental release, we went from 2015 to 2015.1. We found a few issues with that. The most notable was that you as the user had to update your license servers. So anytime that we increment the product to 2015 to 2015.1, or even from 2015.1 to 2016, you as the user have to update your license servers. That is because Helius PFA is sold as term NLM, which is Network License Manager. So that means that it works with like a Flexera licensing. So we wanted to get away from that, from this incremental release, because we don't like updating license servers any more than you as the customer do. So we decided to go with a subscription advantage pack. And that is the main reason for that, is so you get the updates, you don't have to increment your licenses. They will work with a 2016 license server. If you're a new user, no worries on your end either. We have replaced the download on my account for you as new customers. That means that if you download the product, you get the updates with the SAP automatically. You don't have to update the product after you download it. So again, how do I get it? Current customers, this is going to get pushed directly to you through the application manager. The application manager sits in your icon tray on your desktop. If you have the product installed, it will notify you that there's an update. You can go update the product, and everything is solid from there. You don't need to worry about it. It'll do it for you. You don't have to go through pesky downloads or anything. It'll swap the files. We have retained backwards compatibility here. Even though we've added a ton of new functionality, there's still ways to use the old versions if you need to do that. New customers, again, you just download the replacement on my account, or the location where you download products, and it'll be there for you. Finally, for Linux customers, that download has actually been incremented. So if you install in your Linux cluster, you now have backwards compatibility as well. The new Windows versions will point to that new Linux download as well, or that Linux location. No worries on that side. All right, so let's talk about what's new in this SAP version. So as Helius PFA, we typically release twice a year or biannually, and there's a few reasons for that. The first one is that most of the FEA software packages that we support, such as Abacus and Ansys, are on release cycles which are more than 1x per year. They can be anywhere from 2 to 5x per year, usually what we see. So we release biannually so that we can pick up all of these updates from the FEA platforms, because we know you users, you're picking up those new downloads too. So this version, we're gonna have support for Ansys 16.0, 16.1, and 16.2. Abacus has not come out with 2016 yet. We do support Abacus V14 and 14.1, so we should be good there. The other reason that we release biannually is so that we can feed you as users all the updates that we've provided to the product. As I mentioned, we iterate really quickly over here on the Helius team, so we want to provide you those updates as quick as we can, and we also want to provide you any beta functionality that comes through. So a lot of the times when we perform these types of mid-year releases, we'll include some beta functionality, expose it to you as a user if you want to use it, and you can test it out and give us feedback, and then we can move forward from there. And none of the beta functionality will be in the code that you use. You obviously have to be able to turn it on via some special method, but it's a way for us to keep connected with you as we iterate quickly, and you as the customers iterate quickly as well. So let's talk about the updates. We've improved a lot on the mapping side of Advanced Material Exchange. Specifically, now we support any element that you want to read into Advanced Material Exchange. I'll talk about that more in the next slide. We also support injection compression molding. So we support injection molding right now. We're adding support for injection compression. We'll have some visualization enhancements coming your way. We also support now linear CTEs. If you map linear data over and you only want to do a linear simulation, we'll take the CTEs too. CTE stands for coefficient of thermal expansion. And we also support orthotropic unfilled materials, talc filled, mineral filled. If it's orthotropic, we'll support it. Most importantly and most interestingly, we also added a lot of improvements for material characterization in the form of new data fitting algorithms, and also we have a new material test and fitting package that we offer you as a customer, which is really great. I'll talk about that right at the end of the presentation. So talk about the mapping improvements. And first, I just want to highlight what Advanced Material Exchange does, how it fits into Helius PFA. So this is our typical workflow. We see the Moldflow team and the CAE team as separate groups, and the data from the manufacturing simulation up on top. We use Advanced Material Exchange to pass that data to structural simulations. So fiber orientations, residual strains, material properties from Moldflow, those all get transferred to the structural simulation using Advanced Material Exchange. And that provides us a lot of capabilities, because a lot of the times we assume an isotropic response down here, and we know a lot of these materials are orthotropic, so we want to include that data on the structural mesh to get more accurate results. So once the data is mapped using Advanced Material Exchange, Autodesk Helius PFA picks up that data and uses it in conjunction with the FEA solver. So we like to think of Helius PFA as a platform for advanced material simulation. It uses data from AME to drive that simulation. It has convergence technology built in for implicit runs. It understands differences between fiber and matrix degradation. So it's really like a turbocharger to your FEA engine. Advanced Material Exchange is the fuel to drive that turbocharger by providing it the data that it needs. So let's talk about the updates. When we've been working with our current customers and our potential customers, we've noticed that there is an issue with the amount of elements that we support. So on the screen are all the elements that we support for Abacus and ANSYS. The problem is that a lot of the customers and potential customers, you're using more elements than this. 20 node hexes, you can be using wedges, you can be using rigid surfaces, analytical surfaces, spring elements, contact, whatever you want to call it. It's usually in there. And Advanced Material Exchange has a history of not liking those types of elements. So we said we need to go back and we need to fix this. So we removed the dependency, and now we support any element that you want to throw at Advanced Material Exchange. If it can have map data over to it, we will map the data to it. So we revised the mapping scheme on the front end and the back end. And now the front end will read in any structural model, and it will tell you if there's any elements that we don't support, such as spring elements, contact, rigid surfaces, whatever. And it'll display all the elements that you can map to, and we'll do that for you. Now the mapping has changed. We map to the centroid of every element now, and remember, all we're doing is just mapping the data so that you can see it on the front end. We're setting it up, and then we're going to feed it to the structural simulation where Helius PFA can pick it up. We've also included the mapping on the Helius PFA or the solver side now. So when you run the structural simulation, Helius PFA knows where all of these crazy little points are. It goes and queries what the fiber orientations, material properties, residual strain should be from the Moldflow model, and then we feed that back to the structural model in addition to any non-linearity or linearity that occurs, which is really great because that means that you get more accuracy and more efficiency in your structural simulation. It's way more robust, and we've kind of separated the two processes out for you. All right, so we've also added some visualization enhancements to Advanced Material Exchange, notably cutting planes and data refinements. So I have shell model on the right side of the screen, and I have a solid model on the left side of the screen. I'm putting a cutting plane on the right side, or the left side of the screen, sorry. And I'm going to interactively move this cutting plane. And so whenever we move the cutting plane, we can see what's going on through the thickness. And we're also going to smooth the results for you. So if I move over to residual strains, we're going to smooth the results on the surface of the cutting plane so that you can see what's going on in between. Smoothing just means we're interpolating between elements. As far as new material mappings, we had a lot of customers query about when we're going to support linear CTEs. So with Advanced Material Exchange, we will map over any linear data Moldflow to structural, and now that includes coefficients of thermal expansion as well. We also added support for orthotropic unfilled. So before we could only do isotropic unfilled, we did not support talc or mineral. And now we support unfilled, talc filled, mineral filled. They can be orthotropic and we will map them to the structural simulation. You can do linear or nonlinear simulations with those as well. Let's talk about material usability improvements. This is probably the most exciting features that we've added to Advanced Material Exchange in the past 6 months. I'm going to pause this video here for you. So when we've been talking to our customers, we've noticed a few idiosyncrasies with the inputting of material data to Advanced Material Exchange. First, and probably foremost, is a lot of users don't have that data. So they keep asking us what we're going to do to provide that data to you or how you can get it. Second is there's a lot of constraints on entering material data. So right now, or in the 2016 release, we forced users to have 15 to 50 points for each of the stress strain curves that we require, and they had to be smoothed. And by smooth, that means there couldn't be any tails at the end, there couldn't be any dips in the data, things like that. So we went back and looked at how we could help you out as users, because typically you receive raw data if you're going to be entering your own stress strain data, and you just want to copy and paste that in. So here's an example that I threw together. This is 3 different stress strain curves at 3 different rates or environments, is what I like to call it. And the data is not smoothed. This is some of the raw data that I've taken from a manufacturer, or not a manufacturer, a testing lab. 4,000 something points. This is a lot of data points per stress strain curve. And I'm just going to read a CSV file in containing all that data. And it read all in. So I'm going to scroll down. You're going to see I have all that data, 4,000 something points. And I'm going to ask AME to plot it. And when I do that, it'll go out and smooth the data for me and fit it. Now, it takes a little bit longer than it used to, but at least now I don't have to go through the manual and tedious process of smoothing the data. The other thing that we did is we introduced a new material test, and this is probably the most exciting thing for our user base. And this new material test, it kind of goes in line with the Moldflow material test, so the manufacturing test data. So currently we offer the test for manufacturing test data, and we will test the material for you, and then we will provide you a UDB file. So we're calibrating a whole bunch of stuff on the back end for use with Moldflow. Maybe calibration's about where we're fitting that data so that it can be used with Moldflow. And then we give it to you as the user in your database, and you get to use that data at will. Well, we've done the same thing for mechanical testing now. So if you ask Autodesk to test your material mechanically as well, which means we'll get those 3 stress strain curves for you, we will go figure out what parameters need to be in the UDB file for you by running some dog bone specimens on the FEA side. We will update the UDB file and pass it back to you along with the mechanical test data. Once we've done that, you can put it in your Moldflow database and you can go run your Moldflow problems. That data is available for you to look at in Moldflow, and it will also be transferred automatically through Advanced Material Exchange to Helius PFA. You as a user do not have to enter it again. We will provide the UDB, and the data just streamlines straight to Helius PFA through AME. So we're basically eliminating one of the steps. And I'm going to show you that right now. So this is a dog bone in Advanced Material Exchange. I'm going to play it here. Dog bone in Advanced Material Exchange, and I'm going to import a Moldflow plaque, and this is a standard case. I want to pull in this dog bone and reproduce some of that stress strain data. So I'm going to have to position it on the plaque. So I'm going to go through the interactive alignment steps here, and I'm just going to kind of move it over to where I want it. And you'll see I'm going to get pretty close and make sure that I'm exactly on there, just so those fiber orientations come through right. Cool. And I'm also going to position it in the Y direction. So now I want to make sure the gauge length or the gauge section is in the correct location or in the middle of the plaque as well. Good. Now what I'm going to do is I've read in the input file, the structural input file, and I've read in the study file from Moldflow. I haven't done anything else. Usually the next step would be to map the results and enter your material data, but I'm just going to show you the material data is already there. It came from the Moldflow study file. So these are all the points. They came through with the Moldflow study file. More importantly, the mechanical models used in AME have already been fit, so all your constants are there. So I don't have to enter this material data. I don't have to plot it. My next steps would be to map results and then export. So I've eliminated the step of entering the material data. Anybody who wants their material tested mechanically from Autodesk for use with Advanced Material Exchange, you'll get this functionality straight out of the box.